it should look like they are symmetric with respect to the line y equals x. Okay, so let's see. The first graph, let me go multicolor here. The first graph, x squared plus 3, what is the shape of that graph? What kind of function is it? It's a quadratic. What's the shape of a quadratic? It's a parabola. Does it open up or down? It's up because that's positive, right? And this plus 3, what does that represent? The y-intercept, right? So this is a parabola, 1, 2, 3, that opens up and it has a y-intercept of 3. Okay. So we would expect that if this thing is symmetric with respect to the line y equals x, that's a pretty bad line, but that's all right. Then if this one had a point on it which was 0, 3, this one must have a point on it which is 3, 0. Right? If this thing opened up, this thing should open to the right. So that it looks like it could be the same thing, just on either side of that line. That's not a very satisfying graph. Now, you could do that in your calculator, too. If you go to your calculator, watch this. Okay, so I have the x squared plus 3 is already in there. And here's the graph. I don't want that in there. Okay, let me do it again. So here's x squared plus 3. Graph. And that's what we expected. Okay. Now, the calculator will draw an inverse for you. You don't have to enter it in on any other line. If you look on the program key right there, PRGM, above it says draw. So you go second, draw. And if you scroll down to number 8, it's draw inverse. Okay. Number 8, draw inverse. So hit 8. And now we got to get it so it says the y1 after that. And the way you do that, there might be another way to do it, but the way I do it is like this. I go to the bars key, which is just next to the program, and then scroll over to the y bars, and 1 for function, and there's the y1 where we put that thing. And so now it says draw inverse with y1 after it, saying draw the inverse of the thing we put at y1. And when I hit enter, not graph, but when I hit enter, it draws the inverse there. Okay. Now remember that this function right here had a plus and a minus. So the plus part of this graph is this part right here. This is the plus, the part that goes above the middle. And the minus part of this graph is this piece that goes underneath. Now, would you say, looking at the graph of the function, x squared plus 3, is that a function? Does it pass a vertical line test? Can you imagine crossing in more than one spot? No. But how about the inverse? Is the inverse a function? Does it pass a vertical line test? No. I mean, anywhere in here, it crosses more than one. So that becomes important to us here. This function, this is a function. This is not a function.